Hi everyone, in this video, given a set of data like the one we can see here, we're going to see what happens to things like the mean, the standard deviation, the range, the interquartile range, and other statistical measures when we add or multiply every value of data we have by the same number. So let's get started. Again, the list of data we'll be working with here is the one I'm hovering over right now. And so as a first thing, let's see what happens to all of these statistical measures when we add a number, the same number, to every single one of these values. So for instance, let's say I were to add 3 to every value in our list of data. Well, in that case, this list of data would turn into 6, 8, 11, 12, and 14. And looking at this list of numbers here, hopefully it's quite clear that the minimum value that we have now is equal to 6. The median value, which before was 8, has now turned into 11. Indeed, 11 is the middle value in our list of data here. And so I'll quickly write that here. The median value is equal to 11. And as far as the lower quartile is concerned, which used to be 4, well, now the lower quartile will be equal to the median of this lower portion of our list of data here. So that's the median of 6 and 8, which will equal to the average of 6 and 8, which is 7. So the lower quartile is now equal to 7. Similarly, the upper quartile, well, that will be the median value of the upper half of our data here. So that will be the average of 12 and 14, which you can go ahead and check will equal to 13. So the upper quartile is equal to 13. And of course, the maximum value we have here is now 14. So max equals to 14. And before we look into the new mean and the new values of these measures of dispersion, hopefully you can appreciate that each of the values we see here could have been obtained by simply adding 3 to each of the values we had here. Indeed, the minimum value of 6 is just 3 plus 3, the lower quartile of 7 is 4 plus 3, the median 11 is 8 plus 3, and so on and so forth. So it appears that when we add a number like the 3 we have here to all of the values in our set of data, all of these statistical measures are simply increased by 3. But so what about the mean? Well, for the mean value, x with our little bar on top here, we could calculate it in the usual way. Indeed, if I first point out that there are 1, 2, 3, 4, 5 values in our list here, and if we add all of these values together, we'd have 6 plus 8, which is 14, plus 11, which is 25, plus 12, which is 37, plus 14, which is 51. And dividing 51 by 5 leads to the mean value of 10.2. And notice here that this mean value of 10.2 could have also been obtained by simply adding 3 to the mean value of the original list of data. And so what we notice here, and what will always be the case, is that if we add a number to all of the values in our list of data, then all of these statistical measures, so the mean, the minimum value, lower quartile, median, upper quartile, and maximum value, will simply be increased by the number that we add. And I should say, if we were to subtract a number from each of these values, the same thing would happen. But what about the measures of dispersion? Remember, those are the range, the interquartile range, and the standard deviation. Well, let's see, and I'll quickly write a little dispersion title here. There we go, that's dispersion. There we go. Well, as far as the range is concerned, remember, we calculate the range by subtracting the minimum value from the maximum value. So the 8 we see here is equal to 11 minus 3. And consequently, for our new list of numbers here, the range will equal to 14 minus 6. And in fact, I'll write that here. The new range will equal to the maximum value of 14 minus the minimum value of 6. And 14 minus 6, well, that's equal to 8. And so clearly, although we've added 3 to all of the numbers in our list of data, the range hasn't changed. Next, let's look at the interquartile range, which originally was 6. Now the interquartile range, IQR, remember is equal to the upper quartile, Q sub 3, minus the lower quartile, Q sub 1, where the upper quartile here is 13, and the lower quartile is 7. So the interquartile range is equal to 13 minus 7. In other words, the interquartile range is equal to 6. And so in a similar way to what we observed for the range, we notice that the interquartile range we get when we add 3 to all of the numbers in our list of data is the same as the one we had started off with. In other words, the interquartile range is completely unaffected. Last but not least, the standard deviation here, which we can go ahead and check with our calculator, also remains unchanged. Indeed, the standard deviation for this new set of data is also 2.857, where I've rounded to 3 decimal places. Okay, so in summary, what we notice here is that the measures of dispersion, so range, interquartile range, and standard deviation, are not affected when we add a number to each of the values in our list of data. All the other statistical measures, on the other hand, were increased by the amount we added. Indeed, each of these values is simply increased by 3 as we go from one list of data to the next. But so why aren't the measures of dispersion affected? Well, to understand why that is, let's say we start off with 3 numbers and a number line. So I'll quickly draw a number line here, so that would be 0, and so that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I'll quickly label all that. Okay, now let me make a quick copy of this number line to place under the second column we have here. And I'll do that quickly. There we go. All right, now let's say I consider 3 values, or 3 numbers, and I'll say I consider the number 1, 4, and 6. Okay, now let's see what happens to these 3 values when we add 3 to each of them. Well, clearly 1 will turn into 4, 4 will turn into 7, and 6 will turn into 9. So, placing those values on the second number line we have here, 1 turns into 4, 4 turns into 7, and 6 turns into 9. So as I go from this first number line to the second, all I'm doing is adding 3 to each of the values. And so thanks to these number lines, what we notice here is that all that's actually happening is that these 3 values are being shifted 3 units to the right on the number line, which explains why all of these statistical measures were all increased by 3. But as far as the measures of dispersion are concerned, it's important to keep in mind that they don't actually care about the values themselves. Instead, the measures of dispersion are measuring, or are interested in, the distance between the values of data. And here's what I mean. If I were to consider these 2 values, the 4 and 6 we have here, then it's quite clear that the distance between the 2 is equal to 2. Similarly, if I were to consider the distance between the first value and the last value here, well, the distance from 1 to 6 is equal to 5. And so what happens to these distances as we shift these values along the number line? Well, let's see. The distance between 7 and 9 is the same. It's 2. So this distance hasn't changed. And the distance between the first and the last value here, well, that's equal to the distance between 4 and 9, which is also equal to 5. And so what all of this highlights is that adding a number to all of the values in our data simply shifts those values along the number line, but doesn't change the relative distance between those values. And consequently, the measures of dispersion we have won't change when we add or subtract a number to or from all of the values of data. Okay, now let's see what happens when we multiply all the values by a number. And so let's say I were to multiply all of these values by 2. So I'll write that over here. Let's say we multiply everything by 2. Well, if we multiplied each of these values by 2, our list of data would become 6, 10, 16, 18, and 22. And I'll leave it to you to do, but hopefully it's quite clear that in this case, the minimum value would equal to 6. The lower quartile Q1 would be the average of 6 and 10, which is just equal to 8. The median value would be the 16 we have in the middle of our list here. So the median is equal to 16. The upper quartile Q sub 3 would be the average of 18 and 22. So that's equal to 20. And the maximum value in our list would equal to 22. And of course, we could calculate the mean the usual way. Remember, there are 5 values in our list. And so adding all of these values together, we have 6 plus 10, which is 16, plus 16 is 32, plus 18 gives us 50, plus 22, which gives us 72. And by all means check, but dividing 72 by 5 leads to 14.4. And that's our new mean value. And what's worth pointing out here is that each of these statistical measures is simply equal to 2 times the values we started off with. Indeed, 14.4 is 2 times 7.2, the 6 we have here is 2 times 3, the 8 we have here is 2 times 4, and so on and so forth. So when we multiply all the values in our list of data by a number, like 2, then all of these statistical measures are also multiplied by that value. But again, what about the measures of dispersion? Well, let's see. The range, remember, equals to the maximum value minus the minimum value. So in this case, that will be 22 minus 6. And if I quickly write that, that's 22 minus 6, which is equal to 16. And notice that 16 is equal to 2 times the original range we had, which was 8. So the range is definitely affected by multiplication. Similarly, if we consider the interquartile range, IQR, remember that's equal to the upper quartile, which is 20, minus the lower quartile, which is 8. And 20 minus 8, well, that's equal to 12. And this interquartile range of 12 is 2 times the interquartile range that we started off with. So the interquartile range is also affected by multiplication. And last but not least, for the standard deviation, which you could go ahead and find with your calculator, well, the standard deviation, if I round it to 2 decimal places, is equal to 5.71, which is what we'd get if we multiply the original standard deviation by 2. And so what's clear here is when it comes to multiplication, if we multiply all the values in our list of data by a number, then the measures of dispersion also get multiplied by that number. And the reason why that is can again be explained if we look at our number line again. And so let me quickly draw a number line underneath that third column there. There we go. And I'll say that's 0, 1, 2, and so on and so forth. There we go. And again, consider the 3 numbers that we had seen previously. So those were 1, 4, and 6. Now, if I multiply each of these 3 values by 2, then the 1 we have here will turn into 2, the 4 we have here will turn into 8, and the 6 we have here will turn into 12. And so let me add those values to my number line here. The 1 turns into 2, the 4 turns into 8, and the 6 we had turns into 12. And so to make it clear, as I go from this number line to this one, I'm multiplying each of the values we have by 2. Okay, now remembering that measures of dispersion measure the spread between the values of data we have, let's again look at how the distances between the values we have changes. On the number line we have over here, the distance between the second and third values we have, remember, was 2. But when we multiply all of those values by 2, we can clearly see that the distance between the second and the third value has now increased to 4. Indeed, that's the distance that separates 8 and 12. Similarly, the distance between the first and the third value, or the first and the last value we have, which originally was 5, has also increased, and we can see it right here. This distance here, as I go from the first value to the third value, has now become 10. And so because multiplication like this changes the distance between our values of data, it directly affects or changes the measures of dispersion that we have. So in each of these 2 cases, adding a number to each of the values of our data or multiplying all of the values in our data by a number, all of the statistical measures we've listed here, so mean, minimum value, lower quartile, median, upper quartile, and maximum value, are all affected in the way we might expect it. So if we add 3 or any other number to all of the values of our data, then all of these statistical measures will change by that same amount. Similarly, if we were to multiply all of the values of our data by a number, then all of those statistical measures would also get multiplied by that number. As far as measures of dispersion are concerned, though, it's important to remember that they are unaffected when we add a number to or subtract a number from all of the values in our list of data. Indeed, we had seen here that they remain unchanged. On the other hand, when we multiply all of our values of data by a number, then the measures of dispersion also get multiplied by that number. And I'll say one more thing about measures of dispersion and multiplication. If ever the number we multiply the values by is negative, for instance, if we had multiplied by -2, then to get from the original measures of dispersion to the new ones, we would multiply them by the absolute value of that negative number. So if we had multiplied by -2, we would have multiplied the range by 2, the interquartile range by 2, and the standard deviation by 2, not by -2. But perhaps I'll illustrate that special case in a separate video. For now though, hopefully the goal is met and you have a good understanding of what happens to all of these statistical measures when we add a number to all of the values of our data, or when we multiply them all by a number. All that being said and done, that's it for this tutorial.